So we should start with the basic laws of mathematics or calculus. What are the basic laws we have? If you remember from the mind map in the beginning, we have three equations. We have total derivative, we have triple product rule, we have expansion rule. These are the three mathematical or calculus rules we need to remember. The first one is total derivative. Okay, and this is how it looks like. If we have like variable x, and we need to see the change we have in this variable x, and we know that this variable x is function of other two variables, y and z. Okay, so the value of x depends on y and z. So we can say that any change in the value of x can be calculated if we can quantify how x will change with respect to y and how x will change with respect to z. So just take one of the independent variables, which is y, change it, keep the other constant, and see how changing like y will make changes to x. Then see how changes in z will make changes to x. Sum both of them in order to find the total change in x you have. So in this equation we have these like two terms. The first one, this is the partial derivative of y with respect to of x with respect to y. How x will change if we have changes happen in y while z is constant. The other one, partial derivative of x with respect to, this should be z. The partial derivative of x with respect to z. Okay. So this one tells you how the value of x will change if we have changes in z while y is constant. If you can calculate these two partial derivatives, sum them together, then you can find the total change that you have in x value. Okay. This can be applied to any other property. So let's say, for example, if we have internal energy. So this x, let's say, for example, internal energy. So we can have here this x internal energy, this x make it internal energy. Let's say y is temperature. So this one can be temperature. Okay, this one can be temperature. Here we have this y can be temperature. Z, let's make it pressure, for example. So this z can be pressure. So here this z, this v can be pressure. So you can rewrite the equation to see how the internal energy will change with respect to pressure and temperature. du, the total change in internal energy, is du by dt. The value of internal energy changes if you have temperature changes. Okay, plus du by dp, the value of internal energy change if you have pressure change. Okay. So this is one of the like basic laws we can use to find the change we have in any thermodynamic property. But the key here, you can't have any partial derivative in your mathematical model. So the whole problem you have in your mathematical model, or when you know that your mathematical model is finalized, if in your model you have partial derivative like this one or this one, so this means this is not the final form of your model. So the whole key that is to remove all partial derivatives and replace it with like properties that you can measure or properties that you need to calculate. But if the equation have partial derivatives, so this means you are not done yet with your model. You still have more steps to be done. And this is the figure that we explained in the beginning, which is this figure here. So if your model have any partial derivative, so all the steps that we are doing, we are trying to replace this partial derivative with other variables that we can measure. So here we replace this partial derivative with this heat capacity at constant pressure and temperature. So I remove the partial derivative. I don't need the partial derivative in my equation. I need to replace it with any like thermodynamic property. Okay? So if we start with the total derivative and we need to remove this partial derivative, so these are the two rules in calculus that we know. We have triple product rule, we have expansion rule. Any one of them you can use to remove this partial derivative or to remove this partial derivative. Okay. And what did these two rules says? The triple product rule, it says if you have like any three variables, x, y, z, for example, so you can multiply these three partial derivatives together and the result will be -1. So du by dy at constant z times dy by dz at constant x times dz by dx at constant y, the summation of this triple product is -1. And it's important to make sure of the like how you put the variables. So here you have y, and y will be the first in the second term. Here you have like z, and here you will have v in the second one. And then here we have like x, and x is repeated here. And then we have here this one. So dx by dy, so this will be at constant z. dy by dz, this will be at constant x. And the last one is dz by dx, this is at constant y. So make sure that you put the variables this way. Okay? So the arrangement of the variable, this is very important in this one. You can rewrite this equation or this triple product in this form. You can say, just put one partial derivative on one side and the other two partial derivatives, move them to the other side of the equation easily. So this is the triple product rule. The last one is the expansion rule. An expansion rule here we have, if you have partial derivative, you can replace this one partial derivative with these four partial derivatives. Just one, replace it with four. And again, the arrangement is very important. So here we have dx by dy at constant z. So here if you have x, so x will be the one in the first term here, and x will be here. Then we have y. So y will be repeated here, and y will be repeated here. Okay. Then it's called expansion because we are adding more variables to this one. So we start with x, y, z, but we add two more variables. The first one is k, and the second one is L. So again, it's important that to put it in this order. Don't mess with the arrangement of the variables in this one. Okay. So these are two rules that we can use any one of them. So the first one, triple product rule, if you have partial derivative you need to remove from your mathematical model, then you can use this equation. You will replace this partial derivative with two partial derivatives with the same variables, x, y, z. No new properties or no new variables are defined in this one. Or we have expansion rule. If you have partial derivative, we will replace it with four partial derivatives. Plus here we are adding, instead of x, y, z, two more thermodynamic properties of variables are defined, which is k and L. And then x, y, z, k, L can be any thermodynamic property. Temperature, pressure, enthalpy, entropy, so any of the thermodynamic properties that we can have. Okay. We have some other basic calculus rules, which is derivative of two variables, dxy. This will be the first variable times derivative of the second one, plus second variable times derivative of the first one. So this is the one of the basic rules we have. Second derivative of any variable like d2x dy dz. This is d by dy, dx by dz, or d by dz, dx by dy. So these are the same. Any one of them, the arrangement of this one, any of these forms are the same, regardless of the order of the variables that you have in this one. If you have dx by dy at constant x, so if you need to see how this variable will change and at the same time you have constant x, so the result for this one will be 0. If you have dx by dx, the change of one variable with respect to itself, so this one will be equivalent to 1. So all of these things that you will see in the derivations, and then you need to play with these things to see when I can cancel this partial derivative, when I can remove it and substitute with one in it. So as a summary of all the basic calculus laws we have here, so this is the one we have. So we have the total derivative, we have the expansion rule, we have the triple product, and then we have some basic calculus that we can use. So all of this equation that we can use during the mathematical derivation of your model.